We have a CO2 laser fiber coupled to our photonic crystal sample. The photonic crystal is being imaged by an infrared linear array. The light that is not extracted by the photonic crystal is being picked up by this infrared camera. The infrared camera has a bandpass filter on it, and this will help us differentiate which wavelength of laser we're using as the source. So over here on the oscilloscope, this shows the output from the linear array, and on the laptop is the output of the infrared camera. And there's a spot over here. When we're passing the lower wavelength, this spot will be blocked. We won't see anything as it is now. Now I'm going to adjust to the longer wavelength, and now we see that the light is being passed through the bandpass filter. Okay, so this is one wavelength, and this is a shorter wavelength. So going back to the linear array output, we have the longer wavelength and the shorter wavelength. Longer, shorter. And the image on the camera is proof that we are changing wavelength. The wavelengths output by the laser are very close together relative to the design wavelength of this photonic crystal, which is 10.9 microns. So we don't expect to see a very large shift, but we do see a shift. Long wavelength, short wavelength. Long wavelength, short wavelength.